with the Addis Ababa rainfall, you see a negative correlation. But if you look into the data in detail, you see the June observation in June is clustered here. Observation in July is clustered here. Observation in September is clustered. August is clustered here, and September is clustered here. So this negative relation is actually coming from the seasonality. So when you average June to September rainfall delta IT and plot against total JJS rainfall during each year, there is no correlation between them. So the amount effect is not the driver for this relation. So we need to explore what are the dynamics behind this relation. So I did some regression analysis with different atmospheric parameters. In this figure, the shading show the regression between PC1 and SST, and this contours show the regression between PC1 and sea level pressure, and this arrows indicate 850 hectopascal wind. And this is same for delta 18. Note that this here delta 18 is multiplied by -1 before doing this analysis, so that I can compare this figure easily. So what happens here? You can see this SST is showing a La Nina-like pattern, like a cooling in this entire Pacific, and you get like a warming pattern in extratropics in Pacific, as well as in some part of Atlantic. So what happens and also the pressure regression with pressure show high pressure anomaly in entire Pacific region and low pressure anomaly over this region. So this pressure differences causes a wind anomaly from high to low. So you can see winds are going here westerly till here, and also here, and from here winds are going easterly towards India. So from Pacific as well as from Atlantic, winds are converging to this Indo-African region here. So that's why we're getting more moisture in this region and more rainfall in this region. So when I did the same analysis for delta 18, delta 18 also shows similar pattern in SST, sea level pressure, as well as in wind pattern. So in order to understand this dynamics in detail, I did a regression of zonal wind on different atmospheric levels. This is 850 hectopascal level, and this is 150 hectopascal level. So at 850 hectopascal level, as I shown in the last diagram, you can see negative anomalies here, which means an easterly wind flowing from east. And here there is a westerly wind. So wind. Okay. So when you look at the different levels in the atmosphere, this pattern is actually getting reversed, okay, and getting more significant when you go to the upper atmosphere. So this relation between zonal wind and PC1 is strong at the 150 hectopascal level, and it is weak in the lower level, and the signs are reversed here. Wherever you see a positive anomaly here, you see a negative anomaly here. Okay, here you see easterly anomalies. Here you see westerly anomalies. Okay, so to know why this is happening, I did regression between PC1 and atmospheric thickness. This is too much into atmospheric dynamics, so I'm not explaining everything in detail. I will just try to make it as simple as possible. So this is actually a negative thickness anomaly, which means if you look at the atmospheric column, the height is reducing here and height is increasing here. Okay, so what actually happening due to the cooling in Pacific here, as you see this cooler anomalies in the tropics and warmer anomalies in the extratropics, causing this pattern in the atmosphere. That means Cooling of this tropics here reduces the length of atmospheric column, in simple words, and increasing the atmospheric column here. So this causes a high pressure in the top of the atmosphere over here. Okay, this high pressure enhances the tropical easterly jet stream. If you go to this slide, okay, this is where tropical easterly jet stream originates. So when you have more high pressure anomalies over this region, this circulation will get strengthened. So that's what we see in this diagram. This tropical easterly jet stream is strengthening because of this height anomalies. Okay, this height anomalies are actually coming from SST anomalies, which I showed in this diagram. Okay. So that's the whole dynamics here. The SST anomaly leads to the thickness anomalies in the atmosphere, and that causes an easterly jet in the top of the atmosphere. So this anomalies will get reversed in the lower level of atmosphere because of thermal wind balance that is too much into atmospheric dynamics. I'm not going to explain this. In simple words, when you have a meridional temperature gradient, you will have a reversal in wind direction from top to down in the atmosphere. That's called the thermal wind response. So that's a story about the dynamics of this coherent mode or in rainfall. So now coming to the isotope. So this figure shows the regression between JJS delta 18 of P with the moisture flux at 850 and 700 millibar level. These are the levels where most of the moisture is transported. So I did the regression for these levels. Again, here I multiplied delta 18 with -1 so that the figures will be consistent with what I drawn for PC1. Okay. So what I see here is more moisture flux from Atlantic towards Addis Ababa. Addis Ababa is somewhere here, like Ethiopia here. So more moisture flux from this region to this region. So I will explain why this is important for isotope, because Addis Ababa generally get moisture from Indian Ocean, but in some years, more moisture flux come from Atlantic to Addis Ababa and gives more depleted delta 18 now. This is because whenever the rain moisture coming from Indian Ocean to Addis Ababa, it is actually the first condensate. Addis Ababa is the first place where the rain is happening from that cloud mass. Where, at the same time, when moisture is coming from Atlantic towards Addis Ababa, a lot of rain is happening here. So all the heavy isotope will condense, preferentially condense here. So remnant vapor will have more negative isotope anomalies. So this leads to a depletion in Addis Ababa delta 18 here. So to check this hypothesis, I did a back trajectory analysis too. Here, this diagram show the back trajectory of air parcel reaching at at 500 meter above surface in Addis Ababa. So during enriched years, you see more trajectories are coming from Indian Ocean. For depleted months, the Indian Ocean trajectories are still there, but you get more numbers of trajectories from west. Okay, so this is on a monthly time scale. When I did on interannual time scale, like for the enriched years and depleted years, this effect is still there. During depleted years, you get more trajectories, which is actually coming from west. So this westward component or this westerly component is actually reflected as negative isotopic anomaly at Addis Ababa delta 18. So my major results are the study is Indo-Sahel region show coherent rainfall variability during monsoon months, which is actually well known, but the new thing in this study is this coherent mode. This coherent mode is recorded in delta 18 P at Addis Ababa, and this This is recorded in Addis Ababa because of the westerly moisture flux from Atlantic during the wet monsoon years. So the wet monsoon years means like positive anomalies of PC1. So next question is, can we apply this to a real proxy? For that, I took a Delta 18 record, published Delta 18 record from Achara Cave, Ethiopia, which is actually very close to Addis Ababa, around 100 or 150 kilometers from Addis Ababa. So this is the year of one of precipitation from 1901 to 2002, and here the red lines indicate the PC1 and blue line indicate the time series of Speleothem Delta 18 from Machara Cave. You see on longer time scale, they agree very well. So we wanted to know whether this coherence is coming from the dynamics which I explained previously. So for that, we did a correlation between PC1, this PC1, and Speleothem Delta 18 with sea surface temperature. And here we see this again, this line kind of cooling in Pacific and warming in extratropics for PC1, as well as for Speleothem Delta 18. So overall, this kind of meridional temperature gradient, which means the cooler equator and warmer extratropics, create this atmospheric dynamics and gives rise more rainfall in Indo-African region. So the final conclusion is the leading mode of Indo-African rainfall variability is well recorded in rainfall Delta 18 and Speleothem Delta 18 in Ethiopia. Thank you. Any questions?
Thank you so much, sir. I mean, you could stop presenting your screen while we have our discussion. Yeah.
Okay.
It was a very interesting talk, especially, I mean, the possibilities if we could, expand this into, say, the early parts of the Quaternary. So it's looking at Pleistocene data. It'll be really interesting. I mean, especially for me, because I work on Paleolithic archaeology, but it's a wonderful, wonderful insight. I open up the forum for discussion. If anybody has any questions, you could either type it down, or if you want, you could unmute yourself and ask these questions. Currently, yeah.
Hello. Can I ask a question?
Yes, sir. Yes, sir. Yeah. Please go ahead.
Hello. My question is regarding your principal component analysis. You say the explained variance is very low, 14% only. So there are two questions.
Yeah.
Then how reliable these your relations are? That is the first question. And second question, which are the variables that you included to generate your, your principal component analysis? Yes.
Okay. Okay. I used gridded rainfall data for this principal component analysis. So it's like a time series of rainfall at every grid in that domain at around 0.5 into 0.5 degree resolution. So the explained variance is low because we are considering a large region and we are getting loading only over some small region. Okay. So this small region is located in such a way that we get like these areas are important because one is exactly over Sahel and another is exactly over India. And another important thing is, though the leading mode explain only 14%, it is really important when you consider the all India monsoon rainfall, because the correlations are so high when you compare correlation between PC1 and Indian summer monsoon rainfall as well as Sahel rainfall.
Professor Kali, if you have...
Yeah, regarding,
yes.
The variables. Within PCA, how many variables were there? And which are the dominant variables? Is it time series only? Some data?
Yeah, it's time series of rainfall only.
For how many? It is grid. not first.
Yeah, it is gridded. Yeah, it's I can say like approximately 200 into 40. That many time series.
Okay. Thank you.
Okay, you're welcome.
Sure. Anybody else would like to ask Dr. Midhun any questions?
Yeah, I'd like to ask something.
Yes, ma'am, please.
Can you hear me? So I just want to know, can you explain a little bit more how you can actually extrapolate and take it to proxy to longer time depth, say, I mean, Holocene, Quaternary. It would be really interesting. So,
Yeah.
what would be the thing? And do you think that in the past also you would be able to get this? I mean, what would be the requirements basically? Because in the proxy, we work with proxy data, so
Yeah.
not as simple as directly getting gridded measurements. So
Yeah.
and
Okay.
already there's lots of limitations there. So your thoughts on that?
Okay. My idea for this study is actually basically to understand some key location where we can reconstruct some major modes of climate. So in that sense, if you have a longer proxy from this region near to Addis Ababa or in this Ethiopian region, you may be able to reconstruct this major mode of monsoon and Sahel rainfall variability. For India, the Delta 18 observation from Calicut and New Delhi show that like they do not show any significant correlation to the PC1. So these proxies, I don't know like how good will be they for when you want to reconstruct such a coherent mode. But if can I share my screen again?
Yes, sir, you can.
Yeah. Just a second. It's not coming. I'm not getting my Windows. Sorry.
No need to worry, sir. We have time, so you could take your time. No issues.
You have to choose present now.
Yeah, but it's showing some error. So it's saying you must grant permission in order to. Okay. Okay. So if you look at this graph or this figure or this figure, this PC1 caused like more moisture flux towards Addis Ababa here, and similarly you see like there is an enhanced moisture flux towards this northwestern parts of India. So 18 records from this region, I hope they will also capture this signature because I have published a paper 2 years back where I found that whenever you have a more this kind of an component like component from Bay of Bengal or whatever, like when you have a circulation in this direction towards Ahmedabad or northwestern region, you get more depletion in isotope rainfall isotope. So 18 based proxy from northwestern region would be useful to study this kind of a mode.
Okay, thank you.
Yeah.
Thank you, ma'am. Anybody else has any other further queries? I mean, we still have a lot of time, so there's no issues.
Normally I present so slowly, so I thought I will exceed the time, so I presented it so fast.
Well, no worries, sir. No worries.
Can I come in?
Yeah.
Yes, ma'am, please.
Okay, this is Snigdha Ghatak from Geological Survey of India. I have a very basic query because I missed out the first part of your presentation. So
Okay.
basically, you have taken graded rainfall data over a time series, and
Yeah.
what is the time span you have taken?
Sorry?
What is the time span for this? I mean, how many years or so? What is the compilation span?
Yeah, in my first part of my this today's talk, I used time series from 1969 to 2016 because I have a isotopic observation for the time window, and for my later part, I used 1901 to 2002 because that's the time when I have the speleotherm data.
Okay, so now many of the speleotherms actually also have yielded results from that, and I will also come back to the questions that was put forth by a few of other attendees to this meeting. So basically, there are speleotherms which are not only giving you data for the recent past, also we get data from the I mean, couple of thousands of years ago. So within Holocene period. So now, say this is a model that you have established, and what would be the kind of, because here you can establish a pattern. You have established a pattern between Sahel and this Indian this thing. So going by the analogy of this, and if we try to extrapolate this data to the speleotherm data that is already generated, would that be a good possibility? Because to use this as a proxy, and we try to find out what kind of rainfall has been there, or what, going by that delta 18 values.
Yeah. Definitely that is possible, but the issue now is that we do not have any long record, delta 18 record, speleotherm delta 18 record in this Sahel region, or even in Ethiopia there are like multiple records, but the problem is like there are a lot of effects within the cave, so which actually limit our capability. So I choose one record because that was well suited for such a study, because it has a nice smoothing effect, which means rainfall over years are integrated into the signal. But in some case, what happens is the delta 18 records, the delta 18 there is strongly affected by seasonality, and you get a lot of noise. So it's hard to get this kind of signal. To answer your question, there is no much delta 18 records, good records from this region available now to say how this mode varied in the past 1,000 or 2,000 years.
Okay, thank you.
You're welcome.
Thank you, ma'am. Sir, you could stop presenting your screen if you wouldn't mind. Yeah. Do we have any other questions? If not, I would like to take this opportunity to thank you, sir. Thank you for joining us this early in the morning or late in the night. Thank you for your wonderful talk. I'd like to extend my gratitude to the Association of Quaternary Researchers and my fellow members of the ECR team for organizing it. I'd also like to especially thank all the attendees, and a special thanks to the ones on YouTube for bearing with us during some of our technical difficulties earlier today. But before we go, just a little announcement. as a special treat for everybody and it's a continuity of the ECR series. On the 2nd of November, we will be having a little intro session introducing INQUA, their mission, activities, and the role of ECRs that will be hosted in our webinar series. So the presentation will include INQUA's mission and structure, funding opportunities also, which would be helpful for early career researchers, will be illustrated, as well as new funding schemes that they're planning from 2021 onwards. So this particular presentation will be available for all. The same registration link is acceptable and continued. And if you want to know more, we will have these details up on our Twitter page soon. So hope you guys can join us then too. And we'll see you next week for another talk. So until then, thank you so much and see you all.
Bye.
Thank you, sir. Bye-bye.